Hey guys, welcome to the second part of this Substance Designer 5 video where we're going to build a squash node. So in the previous video what we have done is actually starting building the pixel processor, and what we have right now is something like this. Let me check here. So basically it's something, actually it's not exactly that what we want. I have been fooled. But it was work in progress, so it's perfect. So what we have is something that squash in the middle to have a trapezoid shape. So that's something that we want, but right now the problem is it duplicates the shape here. So we're going to fix that. Let me see the math in the other graph here, because it's really simple, but it's a question of order. So basically, yeah, after the division I have to multiply by 0.5 and to add 0.5 in order to make an offset of the result. You know what? Let's copy this. We go here, squash tutor, pixel processor, edit, and copy it here. Okay, so we create a float of 0.5 that we multiply by the result of our division, and then we add again 0.5, and we're going to plug that here, and you see right now the offset is correct. So if I play with this, with the strength that we define, you see that when it's 0 there is no deformation, and you can go up to 1. Actually you can go up to whatever you want, but after it can start to get crazy. But you know, so you have something interesting. But right now what we want to do is to make sure that we have the same effect on the y-axis, so it's like squashing but in the middle of the image. Once again, if you are not interested by that, maybe you just want something to do that, that's possible. You just stop here, and you can have like already pretty interesting result. Now that we have something interesting, I'm going to take something a bit more easy to read. So for example, this, I think this is cool, but you know what, I'm going to take the shape here, and maybe instead of this I'm going to add another shape. This, for example, could be funny. So it was that, and now it's like this. So let's go back into this, and to get to the y-axis we won't do everything again because we are lazy, huh? We don't want to suffer too much. So I'm going to move the strength. We are going to keep x here, y here, the strength here, and I'm going to move all this and do Ctrl D to duplicate. And we are going to plug a few stuff differently. So for example, if I take this and this, for example, if I do x, it should invert the value, which is fine, and let's plug it here. So something is wrong, I will check. Let me check that. It's quite cool, but that's not what we want. So there is something I have to replug somewhere. Check. Okay, before I want to invert, I'm really going to move that down like that. I'm going to plug it now, and of course here it doesn't work, so that's where I have to do some math. So in theory this doesn't change. Actually this is something that I have to invert, but x and y should be inverted in theory, but apparently I forgot something. So as I already struggled with this, I don't want to make you fight for hours, so let's see that. Y, I will do the same. X, because X is not involved. Okay, and Y is not involved here. That's why, apparently, which is weird. This, don't worry, it seems impressive, but it's not that much. We're going to see that later. So, let's see. Yes, quotient density is the same. Actually, could have done, as it's the same, I could have done in the same value. I multiply by x and y. Okay, so should be somewhere. Okay, let's see. Let's go back. Let's go back here, and so it's because this actually is going. Let me check. Okay, and this extremely interesting. I don't know what I did differently than before. Sorry for the delay, it's always happened, but theory, this should be there. And if I move now this, it works. Actually, it's quite cool already, but that's not what we want once again. And we put 0.7, and this should be there, but it doesn't work. Let me check. Let me check something. No. I'm just trying to find what is the good way to make it work. What is weird is that in theory it should be like that. I'm going to go back here. Once again, Pixel Processor, edit, and I'm going to take a screenshot. Actually, it's because the x and y value are influenced by the strength. That's why it doesn't work directly. But okay, it should be directly by the quotient intensity. That's why. Because actually I'm too advanced, because I wanted to add nodes that are not supposed to be there yet. So if I do that, I go edit. What I have to do is, instead of putting the multiplication first, I'm going to put like that, and like that. And let's see now. Okay, this is working, but right now it does like a zoom, because actually there is no, as it's the same squash in both directions, it doesn't make sense for it right now. But what we're going to do is to go back here and let's add a gradient map. like that. Let's take a gradient linear like that, and I'm going to plug it here. So we're going to use this gradient like that. This will be actually what will drive the strength of the squash node, and that's why I had an error before. So let's go back here, and what we are going to do is to call a sample node. I'm going to put it color because actually after we're going to use just X and Y differently, but so far it will just plug the image one, sorry, and I'm going to use to swizzle front one for X and Y once again. So far we are going just to do for X because there is just X involved, and that's where we have to do the math that I did before. Like that. Here we go. X. Let me check that. X is good, good. And let's play with the value. And now you see that it does stretch in both value. The thing that yeah, here I had to invert that, I think. Let me check. No, it should be that. And you see, so you have something interesting, but what bothered me is that it should be symmetric in both axes. And it is, but according to that, I don't know why it doesn't tie on this one. So 1 minus, multiply. What I'm going to do now, just to make sure. Oh yes, actually it works. It's because as the image here is a gradient in this direction, actually there is one direction where it doesn't have that much effect, especially here. So what I'm going to do now is let's make another image. So I'm going to do a transform 2D like that, and I'm going to rotate 80 degrees, and I'm going to use a channel merge, so a GBA merge, and make so this one will be let's be wise, this one will be the Y channel. Okay, I will do like this, and if it doesn't work I will do the way around. And now I plug it here. So now it's not even broken because it still have an x-axis, but I'm going to edit it. I'm going to duplicate this, but this one catching Y. So this is the X channel is controlling is affecting the strength on the X axis, and the Y channel, sorry, this one will affect here. And here we go. You see, we have something that works now. So the cool thing is right now, if you play with that, you can have like extremely cool value. So as we want to see something cool, what I'm going to use is a base material like that, and I will take the height, sorry, as input. So you double click on that, you see the attribute, I say, hey, you know what, I want a height which will be that. Okay, and I'm going to use to plug all this This one is base color. Okay, so everything is plugged now. But I don't know if I can check the normal intensity. Yes, so let's reduce that to 10. Okay, more than that. Okay, so we have something already extremely cool. You see there is some ramping problem here, so in order to fix that, what you have to do is to go here and switch to absolute and fix to 8-bit per channel, and it's already still here, so I think it's because we have to go into the pixel processor, do edit, and in the sampler you don't know nearest but bilinear, and there should be another one here which has the same problem, and here we go. So you see right now you have to put bilinear to the sample color, or if not you are going to have this ramping problem. And just to make sure that we don't use performance for nothing, yeah, you see you both have to put to bilinear and to switch to 16-bit per channel. So now you have something extremely cool, and that offers lots of possibilities. So I'm just going to do, for example, to add a transform here from 2D, and I'm going to divide by 2 the size, and here I'm going to diminish the shape, and you see extremely easily you have like crazy shapes. What is cool is I think with the starburst, is this one, yeah, you have like really funny stuff. Actually I think there is a tile already in here, so I'm going to plug it here, and you can have like crazy value. So let's say for example, so I'm going to play a bit, but what I'm going to do first is to create a parameter that I will call squash intensity, and you have guessed it, I guess. It will be used to expose the intensity. So we go inside, edit, we find where it was here, so we use a get float, we catch the intensity, get boolean, sorry. Okay, better this way. We catch the squash intensity, and with shift left click we move that. So quite interesting. I'm going to put a nice material because let's put iron to see what we can do with that. And now it's just a matter of playing with it. I say we can play. You can change the intensity here. Doing this way. So you define what you want like that. The cool thing is that you can also change the input for the strength, and you can do it in both axes. So for example, let's say what can I take? Let's type pattern and see what we got here. So for example, if you use Gaussian, just to see, on one axis, you see you have something completely different. If we use it on 2 axes, still something different. If you change the strength, you can have like, let's put 5, and have like crazy amount of stuff. And if I do it with that, I don't know what it will give. Here things really interesting, but let's put the tiling a bit up. Oh, nice. Why not? Okay. Maybe I want to put on one axis. Maybe this one was better. Maybe I want to invert that, I don't know. Why not? So let's do invert grayscale. See? So you get the idea. You can do tons of different stuff here. If I go here and I push the tiling, we can do once again crazy stuff just by tiling this and not tiling that, for example. So here it is. What I may do in I will stop the video here. I guess you got the point. So basically right now you have a graph that allows you to create like an insane amount of interesting patterns. What I would like to add maybe in a small video next time is just right now, as you see, it's always tiling. Sometimes you don't want it to tile, so I can show you. Sadly, so far, maybe it will change in the future, but so far you cannot remove the tiling of on the pixel processor node. Actually, if you go here, you go on the pixel processor node, even if we change the tiling mode, it won't affect anything. That may be something that will change in the future, but so far you can do it directly in the pixel processor. So basically what I will do is to say in the next video, if the value is below 0 on the x-axis or on the y-axis, or if the value is above 1, just output black, and actually it will just kill the tiling. So once again, I hope you like this video. Let's see the result in full screen for like that. So as you can see, once again, you can have really interesting patterns quite easily. You see I did it in 3 seconds once the node is done. So I hope you liked this video. In case you liked it, don't hesitate to share it with people. And that's it. So have a great day and see you soon.